Hey guys, today we're going to be looking at those special systems of linear equations, okay? So special systems where we're looking at the potential of them crossing or not. So let's go ahead and get started with the two things you should have figured out during homework and class time yesterday. The first thing, title, special systems of linear equations. Your essential question, can a system of linear equations have no solutions? Can it have infinite solutions? So there's two types. The answer to both of those questions obviously is yes. From yesterday we figured it out. No solutions happens when the slopes are the same, but the y-intercepts are different. So I'm specifically talking about equations here. Okay. Actually, you can find these on tables, graphs, but we're going to look at equations. And when you're looking at a graph, the lines are parallel, meaning they don't intersect. Infinitely many solutions is what we say when the lines are right on top of each other. We talked about it yesterday being twinsies. So, that's supposed to say they are the same equation, graph, / table. Let me fix that really quick. Awesome, all figured out. Let's go ahead and go into our examples. So, we're given 3 examples, and they say solve the system of linear equations. They don't say what way to solve them in particular. So I'd really like to focus in on the equation part in which you guys have been practicing. I know you guys can do tables. You know you can do tables. We've practiced graphs a lot. So let's go ahead and practice the equations. When you're looking at the equations, the first thing that we really have to do is put these all into y equals mx plus b. They need to be all in the same form, slope-intercept form, in order to see if the slope and the intercept, m and b, what kind of numbers do they have. Because remember, if m and m are the same, but b and b are different, that's no solutions, they're parallel. But if m and m are the same, and b are the same, that's infinite. So, we already have this one in our first example in y equals 2x plus 2. So let's go ahead and rewrite this first equation up here. So we're going to put it into y equals form. 4x plus 4y equals 8. PC sad me. Guess what? That's just never going to go away. So no need to complain about it anymore. It's forever going to be there for you. I don't know why my pen's being so crazy. I'm going to restart my little tablet. PC, sad me. Never will it go away. Oh my goodness. Okay, parentheses, no. We're wanting to get y by itself. Parentheses, combine like terms, nothing. Undo this negative 4x because that's being added or subtracted. 4y equals, these are not like terms, so don't combine them. 4x plus 8. This is a positive 8, so it says plus. This is a plus 4x, so this says plus. Undo division and multiplication. Divide everything by 4. Divide by 4. Y equals 4 divided by 4 is 1. 8 divided by 4 is 2. Now we're going to compare the two equations. What do the two equations have? They're the same exact thing, which means infinitely many solutions. Okay, these ones are the same lines. They're twinsies. There's one on top of the other. They're twinsies. Let's go to example 2. We already have our first equation in y equals negative 5x minus 2. It's simplified. Okay, now let's go ahead and solve for y equals in the second equation. We want to get y by itself. So, any parentheses? No. Like terms? No. Undo addition and subtraction? Yep. We're going to have to undo a subtraction because we want to make y by itself. This, I'm taking away a 5x, okay? So this needs to be a negative 5x here. And then 3 is positive, so it's going to say plus 3. Now let's compare our two equations. First equation, second equation. What do we have going on? M is negative 5. M is negative 5. B is negative 2. B is positive 3. Since the intercepts are different, but the slopes are the same, this is no solutions. They are parallel, okay? If we were to make a table, we would see they would never cross. It's like the backpack problem. They sell the backpack for $15, but it costs them $15 to make it, okay? So no solutions here. This is your key right here. If they're the same, infinite. If the m's are the same and the b's are different, no solutions. Number 3. We already have y equals for this one, so let's fix this one for y equals x plus y equals 6. We want to get y by itself, so we're going to take away x. Take away x. Y equals, we're taking away x, and we still have a positive 6. Let's list out the two m's for our two equations. First one, second one. M for the first equation is negative 1, right here. M for our second equation is negative 1. B, our intercept, is 0 for our first one. B for our intercept in that second one is positive 6. So same slope, different intercepts, no solution. Example 4. Let's practice a little bit of a harder one, okay? One in which we have to make the equations first. So, the perimeter of the rectangle is 36 units. Rectangle is 36 units squared. The perimeter, no units. Okay, the perimeter of the triangle is 108 units. Write and solve a system, that means two equations. Do not combine them together. Write and solve two equations and find the values of x and y. So, we know this first one, just going based off of what we know for the first one, is 4y plus 4y, because perimeter is the outside, plus 2x equals 36, the perimeter given. So let's simplify this, like terms, 8y plus, simplify this, 4, oh, that's supposed to say next there, x equals 36. First equation done. Let's look at that second equation. Okay, 6x plus 24y, just adding all the sides together, equals 108. Let's simplify this one. 6 plus 6 is 12. 24 equals 108. We're going to change both of them into y equals form to see if they are similar. So, 8y plus 4, x equals 36. Take away 4x. Not like terms, so don't combine them. This has to be negative because we're taking it away. Divide everything by 8. Y equals negative 4/8 or negative 1/2 x plus 8 goes into 36. Let's think about this. How many times does 8 go into 36? Not completely. So let's just leave it as 36/8 here and then reduce it. We know that. Does 4 go into 36? It does. That's 9 times, and 4 goes into 8 twice. That's simplified enough. Let's go ahead and rewrite our second equation. So first equation, second equation. Let's rewrite our second equation. These are in standard form, by the way. Okay, we're going to take away 12x, take away 12x, 24y equals negative 12x plus 108, because that says minus. Divide everything by 24. Divide everything by 24. And we will get y equals negative 12 divided by 24. Or negative 1/2, that reduces to half x, plus 108 over 24. Let's reduce 108 over 24. I wonder if 4 goes into 108. Morning. Okay, so 4 does go into 108. It goes into 108 27 times. 4 goes into 24 6 times, but I know that can be reduced to 3. Sorry, need a little room for scratch work. So 27 divided by 3 is 9, and 6 divided by 3 is 2. So I reduced it and found out what about these two equations in particular. What do you guys notice about these two equations? How many solutions will it have? Will it have any solutions? I would like you to just pause your video at this point right here, flag me down during class right now, right this minute, and tell me what kind of solution that this one has. Okay, I'm checking to see if you're actually listening to the video notes right now. All right, here's your on your own problems. Okay, remember just to try putting them into slope-intercept form and determine based off of the equations. Even though it says using any method, practice that skill. You guys have gotten so much better. Here's your EQ. Go ahead and answer your EQ, and your checkpoint is ready. I hope you're having a great day. Bye, guys. Oh, I forgot to show you your answers. Here's what you should have for your answers. Okay. Now you guys have a great day.